In this recording, I am going to uh, go through the approach that AG2's reasoner agent is taking to build the reasoner agents. And particularly, then we'll talk about the Monte Carlo tree search, followed by a walkthrough of the code that I wrote from the scratch to implement MCTS without using AG2. It's the entire uh, search strategy from the scratch without using any abstraction. So the approach for the reasoner agent is like this, right? Where you have a language model. It can be GPT-4o, it can be one of the powerful models which will create, given an input, it will create a plan tree, right? A search space, right? So for example, to solve a particular input or a question, I can follow this path or this path or this path, or there can be multiple other paths also. In an ideal situation, if I can create a comprehensive set of this plan tree, then it's probably like I will almost be 100% accurate in finding out um, if I'm able to find out the right plan from this comprehensive plan tree. 100% of the time, probably I'll be right in answering the input, right? But in the real situation, it may not be possible to create a comprehensive set of all the possible plans that you can have to uh, solve an input, right? So the idea is like to create this different the plan tree and then have a search strategy that can efficiently find out the most appropriate plan based on uh, certain. So in case of MCTS, it is probably the value of that node, right? And we'll talk about the Monte Carlo tracer, right? So this search strategy can be Monte Carlo tree search, it can be a beam search, it can be a language agent tree search, or any other search strategy. But the idea is once um, I have a set of plan created, different uh, paths to solve the problem, which path is the best path for me to solve it, right? So the search strategy gives, let's say, the most efficient plan or the thought trajectory, gives it to the language model. The language model takes the input and the efficient thought trajectory to answer the question, right? That is the overall approach. Now, in Monte Carlo tree search, it uses the Monte Carlo simulation, right? So now Monte Carlo search tree works through selection, expansion, simulation, and back propagation, right? I can run multiple simulation and I can, it's a configurable simulation. The number of simulation is configurable, right? In each simulation, I can create a new uh, node to an existing plan, right? So I can, based on number of simulations. So if I to infinite simulations, probably I'll have the most comprehensive set of plan, right? So in the selection, first, like you choose a node, right? Let's say it's my first thought node. Then after I select, I decide whether to expand that node, to explore that node, or to exploit that node or explore another node, right? So there is a formula called upper control boundary, which decides whether you should exploit a particular node which has already been visited, or you want to exploit another node, right? So this is the formula that decides it, right? So for example, here, um, let's say after selection, it selects this node. This node doesn't have any children, so it will expand, right? And after expansion, it will now simulate to see whether this particular plan gives you a better. So in the ideal situation in the game theory thing, right? If you follow this path, whether it leads you to win or loss, right? But in our case, if this thought, how good that thought is, right, is the value of that node, right? And then once I get that grading of that rating of that thought, I back propagate that rating plus the number of visits and update the nodes, right? So if uh, every time I win, right, the value will increase, the number of visit will also increase if I always visit this, right? Um, but next time when I again run this simulation, this formula will decide whether I should exploit a node that I already visited or I should explore a new node, right? So if you see this Ni is the number of visits, right? If the number of visits increases, right, it the overall value will go down, and in that case, you will exploit another node instead of exploring the same node, right? So this is the Monte Carlo search tree, right? So it's it's trying to, like, through the number of simulations, all um, configurable number of simulations, you decide how many times you want to simulate to actually find out the best combination of a win situation, in our case the best uh, thought strategy or the thought trajectory, right? This logic is what I have implemented in through a Python code without using AG2, right? So this is the code, and I will actually directly go to the core logic, right? So first I created a thought node, right? So think about this as thought nodes, right? The thought node has an input as a parent, as children. This is the value, right? This is what we will, this is the, like every time I choose a node, I simulate, I find out what is the rating of that particular thought, I'll update in the value, right? The number of visits, right? So in the first simulation, if I visited this, right, that is visit one, right? Next simulation also I visit this, then it will increase, it will become two, right? Um, the thought, the actual thought is what will be stored here. And the self dot depth is like how much, what depth when I expand, right? How many, what is the depth that I should go, right? So this is the thought node. This is the logic to back propagate, right? So this propagation logic is this one. Once I have a value, how I back propagate to the children, to the parent, right? And then the actual returning the best node, this is where I run the simulations, right? So I take a number of simulations. Now for a configurable number of simulations, I check. So every simulation, I do this, right? Selection, right? This is the selection, right? This is the UCB formula. This is this formula, right? Which decides whether I should exploit or explore, right? So this gives me, um, it selects the node, right? Once the node is selected, if it does not have a children, I expand it, and then I do the, in the expansion, if I go to the expansion, that is where the simulation also happens. In the simulation, what I do is I uh, let the LLM create a thought, right? So if I look at this thought creation prompt, right? Um, System to thinker role, backstory is you are a system to thinker. Given an input and a list of previous thought, you generate a follow-up thought that can advance the solution to solve the given input, right? That is what the simulation part is doing, right? Here I am um, asking it to create that thought and then rating the thought, right? This is where I'll rate the thought using another LLM and get a value, right? This value is what I'll back propagate now, right? And along with the, um, so if I go to the rate thought, you'll see that not only the rate, right? This is where I grade it, but when I after I rate, if I go to the back propagation part, right? I back propagate the number of visits as well as the node value is nothing but the whatever was the earlier value plus the new uh, in this simulation the new value or the new rating of the thought is what I add, and it is the average of all those thought rating is what gets stored here, right? So this is how the um, this is where the this is what the logic is, right? To select the node, then this is where I'm doing this. After selection, I'm doing the expansion and the simulation and the back propagation, right? And then I wrote a simple program like after you do a number of simulations, if you want to visualize the tree, this structure, right? This structure, if the visualized tree is true, um, it's a very simple print tree ASCII, right? It shows how the thought is, how the thought nodes are created, what are the sub thoughts and all, right? So this is this is what I have implemented from the scratch, right? Now to run it, right? Created a, I instantiated the MCTS reasoner, right? If you see, this class is the MCTS reasoner, right? And then in the MCTS reasoner, I call the generate reasoning, which calls the return best node, right? Which is the best trajectory of the thought, right? So here, me, I was running with multiple inputs. So let me show you a example where I'll say, how old was Rajiv Gandhi when Indira Gandhi became Indian Prime Minister, right? Let's see how it thinks about it, right? So here what I'm doing is I'm taking the input, then I'm calling the generator's reasoning. I get the node, the trajectory, right? And then um, I wrote this code to actually show the hierarchy, and then just um, printing out the thoughts and the follow-up thoughts and all for that particular trajectory. If I run this, it takes some time because it is actually doing a lot of things. I think I'm running it for 4 simulations, and the horizontal expansion, right? The expansion also, like I said, by default, I think I did it 2, right? So it can um, create 2 children's, right? So let's wait for this and see how the thought process comes. Right? It takes some time, but it's actually very expensive as well. It's calling almost, so 4 simulations. If there is a 2 expansion, in if each expand, like each time if it expands, right, it will almost 8 calls, right? And then there is a grading part also, right? For all this 8, so it is a lot of calls to the language model. Uh, but let's see if this gives us it. So it has now. Yeah, so this is the thought process it created, right? Um, so this is the first, uh, so this is the root node. This is the first child node. This is, so this child node or the root node has one, two, yeah, 2 child nodes, and that child node has this child node, this child node has this child node, this child node has this child node, right? So this is one trajectory. This is another trajectory. This is, and this is another trajectory, right? Now, the trajectory for which the value is the maximum, right? It will take that trajectory, and that is what I'm actually um, printing it here, right? So it starts from the bottom is the first thought process. let's see what it says. So first thought process is to determine Rajiv Gandhi's age when Indira Gandhi became the prime minister. I need to know both Rajiv Gandhi's birth year and the year Indira Gandhi became prime minister. Right. Then the next, it says, was born on Indira Gandhi became the prime minister by calculating the difference. So it is actually creating the follow-up thought. Right. Then it saying to be precise, you should consider the exact dates. Right. And then finally, this is the thought it is giving that we should verify the what date of Rajiv and the date Indira Gandhi first took office to ensure our initial calculation is correct and precise. Rajiv Gandhi was born on August 20, 44, and Indira Gandhi became Prime Minister on January 24, 1966. Therefore, Rajiv Gandhi was 21 years old and about 5 months old at that time, right? So it is actually one thought, follow-up thought, follow-up thought, and then follow-up thought. It is actually able to give a very good thought trajectory here. That's all I wanted to show as part of this recording.